That works.
It's on.
Good morning, ladies and gentlemen. Come along, have a seat. Some exciting information about how to discover the productivity of Siemens. We've heard a whole lot this morning already about anything is possible. Starting with our flagship, the 840B SL controller, down to our mid-range machine, the 828 up to 5-axis and all the features and functions. And brand new launched here on the IMTS, the new compact class.
The 808.
Tell us a little bit more about that 808.
They're like a comedy team, these two.
Of course, Matthias. The 808 is the new compact control for basically retrofit knee-mill types or flatbed lathes. It's 2 or 3 axis and it comes as a complete package. We're showing it over here on an Acer mill for a 2-axis setup. Very simple, very easy, very low cost.
Thank you, Randy. Before we go into the details, let's step back a little bit and look to the general industry trends that we are facing in our everyday life. Shorter product cycles, fewer parts per assembly, more advanced manufacturing technologies. Parts are getting more and more complicated, and on the other hand, everybody expects us to have faster installation times and shorter ramp-up for the new equipment that we bring in. That somehow contradicts with what we are trying to do here. Discover the productivity of Siemens introduces here now the broader view. So let's step back a little bit before we look into details here. How do all those plans, products, part programs and designs get to life here? So we have a plan up front. What is that plan about? That plan is usually generated in manufacturing engineering. So there is a whole bunch of people working and thinking of how to best make that part that we, in a form of an NC
and make
program,
the best part easiest to manufacture.
And make the best part easy. Right, to ensure the quality. So in the manufacturing engineering domain, we are mainly talking about importing or getting a 3D model of a specific part that you are asked to manufacture, to produce, and how that could be done. Starting with a part model preparation. Maybe some of the edges, corners, or radians are not in that shape as you actually want and need them for manufacturing. Or we are talking about tooling and fixture design, how to get that part on that machining table, how to locate it, which are the machine coordinate systems. Finally, we're talking about NX-CAM programming to generate a tool path and to post that into NC code that can be executed on the machine tool. Finally, in parallel, that all underlies a process plan. Usually parts are not manufactured just on one singular machine.
They get transferred from machine to machine depending on spindle availability, which operators can handle which type of parts. So we need to be able to make sure it's transportable from one machine to another without extensive reprocessing, reposting, or new setups.
That all belongs to that plan, and in addition to that, finally we want to inspect the quality. What did we manufacture? Did we reach the quality, the tolerances, the specifications of that specific part? That is done in a so-called CMM programming. That's the domain of manufacturing engineering. If we now jump over that fence of the white collars that think everything ahead and drop that manufacturing engineering package down to the shop floor, we see different applications coming to life and coming into play.
Exactly. We need to get the information down to the machine. We need to verify it before it actually runs on the machine so that you know that the part is within all the travels, that the configuration of the part is what you're actually looking for. Take it down to the CNC and actually cut that part and keep the data. All your process information, all your tooling information, and be able to push that down to the inspection guys.
Usually these two domains, manufacturing engineering and production on the shop floor, are quite separated. And productivity comes into play if we can bridge these gaps between that flow of information, fast and easy, right in time, short decision cycles, and that's what we are talking here when we introduce our part manufacturing solution suite. And if I get that thing to advance, part manufacturing solutions is bringing those two work domains together in a seamless working data backbone where we can exchange easily and fast all the information required on the shop floor.
Both ways, to the floor and back up to engineering.
And back up. Yeah, we see a couple of solutions like the traditional DNC solution. It's a one-way solution.
Make changes, make modifications, it never gets back up to the engineering departments.
One of these seamless engineering features that we present here on the IMTS show live, for instance, at that growth machine that you see around the corner here, is the CAD/CAM CNC process chain. What are we talking about here is that we have a bundle of applications that seamlessly integrate into a natural workflow. That means we are starting with a CAD software for part model preparation, alterations, that you could modify your part. And it's not only limited to our usage of our own tools like NX, CAD/CAM, but we can also utilize our latest synchronous technology and work with other CAD vendor parts like CATIA or just to name one here. We then process these 3D model into a so-called CAM environment where we program the actual features and functions that are to be cut and milled on that specific part. That's where we generate a tool path and where we drill holes and face mill or turn a flange also. Once that is done, we push that thing through post-processing, and there is where real interface features come in that are far most advanced what we could ever think of.
To get the correct code from the CAM system through the post so it actually functions in the control the way it's supposed to, utilizing all of the advanced features and technologies that are available so that you can make your part in the quickest and highest quality.
Let's look into some of the key features here that these seamless CAD/CAM CNC process chain can bring us here to life is increased productivity through the entire life cycle of that part and the part preparation cycle. So we would absolutely accomplish increased productivity on our machine tool. And one of the reasons is because all the parts are proven out and verified before it comes to the machine, and we really cut chips on that. We don't use the machine as a programming station where it's standing partly unutilized on the shop floor, and we teach and program on the shop floor. We feed it with validated code, and that's a big advantage.
Yes, it is. We know before it gets to the machine, it should be a perfect program, but then when it gets into the machine with the verification that's available on the machine in a very quick time, you can double check and make sure that yes, it's going to work the way you want it to.
One of the key initiatives that we have here is our close collaboration with the most prominent machine tool makers that you find on the South Hall all over the place, especially with regards of generating and programming qualified post processors that are already prepared for that machine to run all the options and the specific features that you ordered and get with your machine. And we will see later a diagram how that influences the overall productivity of your equipment. Delivering machine tool value at its best requires a little bit more than all that what we are just talking about. So we need, for sure, an advanced CAD/CAM CNC process chain, a software tool with the latest features and functions, but
you also need the know-how from the machinists, from the operators, from the setup people, as well as the tooling manufacturers, so that you get the correct cutting tools and the correct people and fixturing to run the part, down to the control that can process the information in the fastest amount of time and make a quality part. And machine tool, of course, has to be the correct configuration machine to get the part through.
And that is another part where we really bring innovation here to that manufacturing market. where we, as we speak, launch press releases about our latest campaign and initiative about common manufacturing resource library. Complicated word, what does it stand for? That we are extending the DIN standard for tooling catalog data and add new features and functions and attributes to that database and make it a common tool library. You all have been working with that issue that whether you buy a Kennametal, a Niska, a Sandvik or whatever tool, they describe it different in their catalogs. And most of the times, yeah, at the end you end up with typing in tooling features, tools that you need for programming manually in your own tool database. That will be solved with this initiative, that we have a standardized tooling catalog that can just be imported into our tool library to be available from any supplier that joined that initiative. So we pointed out here how that whole CAD/CAM CNC process chain can really reduce lead time and maximize the use of your resources. In addition to that, let's look now into some details of that features and functions. What is the advantage of having a CAD tool inside your CAM tool? A full-blown, full-functionally state-of-the-art tool. That was actually used to design the Mars rover that just landed a couple of weeks ago. We all followed that up on TV shows and were really excited. The same tool in a adapted configuration is used to program your parts here on the shop floor. And you see how easy and fast it goes if you can use 3D modeling capabilities within your CAM tool without the need of exporting and importing back and forth if you just need to do a little change or to design a fixture or to model your tools. It's really a great advantage to have that inside the same CAM capabilities. Two sides. And the other big advantage is that we incorporate here specific cinemeric functions.
Yes, in the post-processor they have all of the advanced cycling capability built in. Through your drop-down menus you can pick from cycle rate 32, the high-speed machining cycle, to set the tolerances, the surface finishes you're looking for, the transformations that would be required to make that part, as well as cycle 800, which is our swivel cycle, so that it rotates to get to the correct plane to make your machining easier on any surface of your part. And Traori, which is simultaneous 5-axis machining, which allows you to program the part surface and not worry about the pivot points of the machine, the tool lengths, or the tool diameters. This makes it a very transportable program. It can go to any kinematics that you would have on the shop floor. And then the operator sets up his tools, and you don't have to repost every time you change from a half-inch tool to a 3/8 tool, or from a 2-inch long tool to a 4-inch long tool. You modify the tool table, and it will run correctly.
And that's really the advantage of having both products, manufacturing, engineering, and execution on the shop floor from one vendor. Because we work so closely together that all the interfaces, functionalities are known to us, and we align our developments pretty much that we can get all the max out of this feature. And we use that actually on that little globe machine that we see around the corner to manufacture a die for that model aircraft here. It's done in carbon fiber technology, and it's really interesting how much of weight reduction could be accomplished in using that advanced technology, so that 8-foot long model aircraft weighs only 20 pounds, including all the batteries in the motor and everything. So it just won the artistic aircraft model show in Germany last month. So we're really excited about that. Thank you for doing that. So we already talked about the high-speed setting cycles and how closely NX CAM with the certified post-processor integrates into the cinemeric capabilities with user-defined operations that just are can be popped up and filled out,
and you choose which functions you want, the features you need to use, and it will write the cycle and run into control.
More than that, it's not only cycle 800, we have general cycles like drilling cycles, like planing cycles, like
Tapping
cycles, where you would find the same operation menu and the same parameter list within NXCAM as you would find it when you did it on the controller interface. That makes operation so much easier for both the offline NXCAM programmer and also the machine programmer, since they use the same.
Easy to make changes. If the guy needs to make a quick change on it, use the cycles, and he can call up the screen and make his changes right on the floor in a matter of seconds, and then send it back upstairs to have the modification registered in engineering.
Yeah, that's really the big advantage. We have been talking a lot about milling, but milling is not everything. We hear a lot about 5-axis milling, and that is one of the reasons why we not only used 5-axis milling on that specific rock machine, we did it all, that mold, in 3-axis, 3+2, 4-axis, and 5-axis, because not every feature really needs 5-axis operations.
Right.
So looking to the mill turn machines, starting 25 years ago as a machine tool operator, I've seen so many machines, advanced machines, 2 spindles, upper lower turret, or the steady rests that at the end are programmed and utilized just as 2 machines on one machine bag.
Programs were written in cyclic sections, so you could turn on one, mill on the other. The synchronization was not really easy to do, but now with the multi-axis, multi-sync functions, allows you to easily use both turrets on the same part, rough and finish with the 2 different tools, do your milling capabilities. Some of the mill turns, they even have 5-axis on the upper turret, so you can actually do 5-axis milling, transfer your part, and also incorporate the tool changer.
That is a real advantage. But we can top that more with having all the knowledge and expertise of the manufacturing engineering and the shop floor execution portion in one house enabled us to include the VNCK into our simulation. What is that all about?
The VNCK is a virtual NC kernel. It actually uses the kernel from the 840D as its processor. You load the archive from your machine tool into the VNCK, and when you do a verification, it's not just a simulated verification, it's a G-code verification utilizing all the parameters and all the functions and features of that specific machine.
So in addition that we provide a general emulated G-code simulation, which has a real advantage, we get the real deal, we top that off with a virtual CNC controller embedded into NX that would give you the most accurate simulation and validation results that you can imagine.
Cycle time, you're going to know how long it's going to take you to run the part before it gets to the floor.
But not all of that. We can extend that thing. We have simple parts that actually are not run out of offline programming. Nobody in the CAM department really does care about that. We have a whole lot to offer on the shop floor programming as well.
The shop floor suite of shop mill, shop turn allows you to take your simpler parts. You're turning a shaft with a thread, you're boring a hole, doing a couple of grooves, running a pocket. With the graphic user interface, it's a basic fill in the blanks type function. You will get an instant verification of your information before you run it. You get a cycle time before you even run it, and you guys on the floor can pick it up in a very quick time.
That's really an advanced feature, how we incorporate that all into a part manufacturing solution suite. Now the good old question comes, show me the money. What is the actual value of that? We brought a little picture here that we based on a few studies that we made in ramp-up time savings. If you have this CAD/CAM CNC process chain, prepare and purchase it along with your machine tool. Actually, it is prepared before the machine tool hits your shop floor. In many cases, traditionally, you get that machine, everybody is excited, foundation is prepared, electrical wires and compressed air, everything is fitted there. Now the big old question comes, how do we program that part? You might have gotten one prepared part that you were using as validation part when you
run it one time and now you sit and wait.
Exactly, and then the big ramp up time losses come into play. You see that red path here in the traditional process, easily we see that 3 months pass by until you really can ramp up that complicated machine to full productivity. If until all your operators are trained and the offline programming is available and you have proven out and validated programs available. With the CAD/CAM CNC process chain prepared up front, when you purchase the machine, we see a drastic increase in time savings and productivity. And that is really where the money comes in. And it makes a huge difference if after 3 months the utilization of your brand new equipment is only 30% or already up to 80%.
Right. And then in a shorter period of time you're at 100% and making money. You don't make money if the spoon is not cutting.
But that is not all. We were talking about CAD/CAM CNC process chain, the traditional model. But in the very beginning, we found out there's lots of data created in that environment.
Cutting data, tooling data, process time, runtime.
Yeah, the entire process plan, work instructions, tooling lists, and all that information is created. And we want to put that and make that available for the shop floor engineer as well. So we decided to develop a so-called Team Center manufacturing suite, which brings that data and makes it available in one common data backbone that can reach out down to the machine tool at the shop floor. You would have electronically available all your work instructions, your tooling setup, maybe a picture or a video clip of how to specifically mount these parts on the toolstone and how it would rotate, critical collision zones, whatever.
Makes your setup faster, get you into production a lot quicker.
To give you just a short impression of how that would look like is, that is our a screenshot of our Team Center Shop Floor Connect solution, which incorporates a DNC functionality. What you see on the left-hand side, there is general information. These buttons, if you read them down, for sure there is an NC program code available that could be edited or verified and compared to existing programs you might have on the shop floor. But in addition to that, you could view the original drawing. If you have a JT viewer, you can see the 3D model of the part that you actually are supposed to manufacture. You could add a little video clip of specific situations that the machine tool operator needs to pay attention to, or a complete list of the shop docs like working instructions, what is to be done first, the whole setup sheet, inspection sheet, the whole 9 yards are available all of a sudden on the shop floor, and not only on the machine tool operation screen or on a PC or laptop sitting next to the machine. We also have that available as a web browse based mobile solution. So you could either use an iPad. iPad is not a good idea. They walk away too fast on the shop floor, do they?
Yeah.
They tend to.
And they get dirty.
They get dirty. But there is real valuable, not too expensive solutions available for any tablets and PC that runs a web browser, can do the whole operation and view that whole set of information down next to the machine on the shop floor. Now we've seen about the CAD/CAM CNC process chain, the upper part of that 12-column diagram here. We've been talking about process planning, tool libraries, shop floor data access, tool management, and DNC functionality, how to get that information down to the operator at the machine. One of the final steps is I need to verify, was that good what I produced?
How do we check the part? How do we know the part's good?
So depending on how your company is set up, you might have CMM programming. And this is another feature to complete that picture that we added into our part manufacturing solution suite. The CMM programming integrated in the same tool, in the same environment, on the same 3D model. We call that PMI data, product manufacturing information, which in the simplest case could be what color will that thing have finally, how is it to be painted, but more traditional, we're looking into tolerances, surface finish qualities,
Full size, bore size.
exactly. All that information is available inside NX as well. So we are really working on one backbone from part to part in that domain here. We put together a little clip about API-driven CMM programming and how it works and what it does. Watch this. This is actually one of the parts we were producing at the DG Morisaki open house back in May this year, where we used the size Grismo. We programmed that part, we manufactured that part in a real virtual to physical environment, where all the 3D models were used in the same environment, where we imported the part, programmed the CMM, and utilized our CMM inspection programming also on that same machine. And you see that nicely, how virtual and physical inspection goes side by side. So with that, we are at the end of our short presentation here. Build the right product and build it right. And I believe with Siemens, how does Casting phrase that? Anything is possible. Maybe a little bit overrated, but a lot is possible. And I think we set here a benchmark of the integration between CAD, CAM, CNC, and shop floor data management. Thank you.
Thank you so much. We appreciate it. All right, thank you everyone for joining us. We have t-shirts with our lovely ladies back here are handing them out. If you've joined our presentation, feel free to have one. And also check our easel right here because we have presentations coming up. Our next one is at 11 o'clock, I believe. Yes, I will be speaking again on Anything is Possible at Siemens. Don't miss it. Thanks for coming.